So yesterday we have done till class, right? Or range also. Till where we have completed. The values. Okay. So N means network. V is on. Okay. You have to memorize this one and this one. Okay. Now moving to the range of IP address. So now we have to see range of IP address. So yesterday we have seen this IP version 4 is divided into 5 classes based on the network size. Now for every class, how we can identify this IP address belongs to which class. So every class is having first block network. That is why we identify class of IP address only with the first block. We have 4 blocks. In the other 3 blocks, what values are there, we are not bothered about it. We are not going to see even. So when we have to identify the class, we will see only first block. In one block, we have 8 bits. So 8 bits. So minimum value will be 0 and the maximum will be 255. So it will start from 000 for the minimum, and for maximum all bit we will keep 1. Okay. So there are some rules using which this IP address has been divided into classes. The rule is first bit must be 0 for class A. So here you can see the first bit is 0 as per the rule, and the remaining bits we will keep 1. So when we are going to convert it from binary to decimal, the value will come 0 to 127. Okay. So this is for class A. Similarly, for class B, it will start from 128 because the range where it ends, next will start after that. So 128 in binary is written like this. As per the rule, class B second bit must be 0. So you can see here also second bit is 0 and here is also 0. To get the maximum value, we will again put the remaining bits 1. And when we convert it, we get 191. Similarly, for other class C, third bit must be 0. Class D, fourth bit must be 0. Class E is the last class. That's why rest all bits we have kept 1. Here we have not applied that fifth bit must be 0 because it is the last class. So that is why the range of every class, if you see class A 0 to 127, B 128 to 191, C 192 to 223, D 224 to 239, and E 240 to 255. So this is how the range is defined. Now where we are going to use this IP and range, we have to define the class. Sorry, we have to check the IP. If any IP address is written, so this IP address belongs to which class? Class A, class B, class C. So how many of you think class A? Raise your hands. Class D, B, class B. Confused, confused. Backside. And class C, just now what I told you, we have to see only first block. So here we have the first block. So what is the value we have? 179. Where it fits? Class B. That's it. After that, what value we have in the IP address, we don't need to see that when we are identifying the class. Okay. Which class? Class D, C. Anyone who is having confusion? No confusion now? So now tell me, both the IP address are in same network or different network? How many of you think same and different? They are in the same class, not in the network. Okay. Then how we will identify they are in the same network or different network? First tell me it belongs to which class? Class C. In class C, how many blocks are network? Three block networks. Yesterday we have seen na. So three block networks mean we have to match three block values. If three block values of both the IP address are same, then they are in the same network. If not, then they are in different network. So they are in same network or different network? Different network. Both the IP address are in same network or different network? How many of you think different network and same network? Confused network. This IP address belongs to which class? How many network? Values are same of one block. That's it. So that is the reason you have to memorize this range also and this one also. then only you will be able to identify any IP address is in the same network or different network. If you don't memorize this, then problem. Always keep in mind, first we identify seeing the first block value. If both are the same, then we proceed further. If not same, directly we say they are in the different network. If it is same, then we first check the class. As per the class, we check how many blocks are network and they are same and or different. Okay. Next is types of IP address. There are four type of IP address, IP version 4 address. First is loop back. Loop back IP address is used for self-testing and troubleshooting. Okay. So the purpose of this is only self-testing and troubleshooting. That is the reason we don't configure this IP on our devices. Understood? So this IP is having some special purpose. So we don't configure this IP on our devices. For that, it is invalid. Okay, so this IP address is used for some different purpose. So the range is 127.0.0 to 127.255.255.255 means complete network of class A is reserved for loopback. Okay. Now where it is used. So for example, you have configured IP and you want to test the connectivity that everything goes well or not, just like echo mic check. Why we do? We just want to say and listen by ourselves. Similarly, here we ping with ourselves that whether device is responding or not. So similarly, other IP addresses are used for the same. Okay, so 127.0.0 to layer. So always keep in mind, if any IP address starts with 127, we will directly say it is a loopback IP address. After that, other things no need to memorize. Only one number is enough. You can say if it is 127, loopback. That's it. After that, whatever value is there, that doesn't matter. Clear? Next type is link local IP address. So what is link local IP address? On computer, we can configure IP in two ways, either manual or automatic. If we configure automatic, we use DHCP server. Suppose there are 1,000 computers in your network. So how much time you will take to configure IP on all 1,000? 3-4 hours. Huh? In counting 1,000, you will take 3-4 hours or more than that. So how you will configure the IP? So going on each and every computer, log in into it, open the network connection and configure IP. It takes a lot of time. So what we do to avoid this all, we create a DHCP server in the network. So automatically when the device is connected to the network, it will send request to the DHCP and DHCP will give one IP address. So configuration of IP is done automatically. Only while configuring DHCP, we define from where to where, what will be the range of IP to be distributed. So we configure this on DHCP server. So there are two ways. One, we can go on every computer and configure the IP manually, or we create a DHCP server that will distribute IP automatically. So the device and server will communicate with each other and take the IP. So by default, all the devices are set to obtain IP automatically. That is the reason when you connect to Wi-Fi, you don't configure IP and you have the internet connection. It happens or not? Mobile also. Have you configured IP on mobile? But when you connect to Wi-Fi, it gets one IP address. So it is set to obtain IP automatically and your Wi-Fi device is set as a DHCP server also. When you check the configuration, you will come to know that. Suppose you have connected your device in the network and by default all devices are set to obtain IP automatically and the DHCP server is not available in the network. So when you are trying to get the IP address from DSCP and DSCP is not available, not reachable, in that case, this is the feature of TCP/IP. We are using TCP/IP protocols. So it is a feature of TCP/IP that this range IP address it will take automatically, and this feature is called a PIPA, automatic private IP address or link local IP address. So it is inbuilt in our operating system, the softwares, that if it failed to get IP address from DSCP, it will automatically take IP address from this range. Understood? So if you want to see the same, then we have one solution here to see. In the simulator, we can check the same. So suppose just to simulate, I am going to take two computers, one another. I'll connect both. Here in simulator, it is not set. In the real computer, it is set to obtain IP automatically. So when it is set to obtain IP automatically, you see DHCP failed, a PIPA is being used. So 169.254, it has taken automatically. Same behavior happens on our devices also. So in these both devices, if you see, we don't have any DHCP server. Both are as a client. You see, DHCP failed, it has taken IP. And what IP it will take, it's not defined. Any IP from this range it will take automatically. So how we will identify any IP address which starts with 169.254? Not only with the 169, 169.254, because it is class B, so two blocks will be matched. Okay. So if it starts from 169.254, we will say it is a PIPA IP address, and we don't configure manually this range IP. So it is also invalid for us to configure. Understood? So if it is 127, loop back 169.254, then a PIPA. Next is private IP address. Private IP address is used in a LAN for our private network. Okay, and it is free of cost. Anyone can use this private IP. Also, I am using suppose 10. You can also use 10 in your network. Why? Because private networks are not connected with each other. Your private network is private for you. My private network is private for me. We are not going to connect both the networks. So there is no chance of IP conflict. Okay. So this private IP we can use, but the problem is using this private IP we cannot communicate in internet. Using this IP, if we connect to the internet, what will be the problem? Problem will be you are also using the same IP, I am also using the same IP. If we both connect to the internet and send packet through the same IP, then it will conflict. This internet will confuse, internet routers will confuse where to forward this packet. You are also having the same IP address, I am also having the same IP address. Okay, so that is why this private IP is not routable in internet. So whenever the private any packet comes with the private IP, immediately the router drop it. It is not forwarded towards the internet. So INA has done one thing, that they have given private IP range class A, one network. Which network? 10, because only one network is there. If it is 11 means public IP. If it is 9 means public IP. Only the IP which starts with 10, that is private. For class B, INA has given 172.16 to 172.31 means what INA has given. INA has given 16 networks I can create private of class B. For class A, I can create only one network, 10. Class B, I can create one network of 172.16, 172.17, 18, 19, and so on till 31. So total network, how many we can create in class B? 16 private networks. Okay. Now, next is 192.168.0 to 192.168.255. So as class C is having 3 blocks of network, we can create 256 different networks of class C. 192.168.0, 192.168.1, and so on. Because after this fourth zero, we will put 1, 2, 3, 4, 5 until the 3 blocks values are same. They will be in the same network. Clear this concept? So these all are private networks, or you can say private IP address of every class. If suppose there is a 192.167, it becomes public IP. Understood? When it will be private, to memorize it, the best pattern is remove this one and remove this one. If any IP address starts with 192.168, it is private IP. If it starts with 10, private IP. 172.16, if it is 15, then public IP. Clear? So like this you have to memorize these numbers. Now the next is public IP address. So public IP address is used for internet communication. If you have a server, you want this server to be accessed by all the users in the world, then you need public IP for its unique identification in the internet. So that is why this public IP address is used for internet communication, and we need to pay. Why we need to pay? Because they need to purchase the register and pen. When they give you the IP address, they maintain the record that this IP address belongs to which person, and that is always unique to avoid the conflict. So that is why we need to pay it. We take as a subscription and then we use it. So all IP address are public except what? Except these numbers which I have shown you. Understood? Except this number, if IP address starts with anything, that is your public IP. Or you can say except loopback, APIPA, and private IP. Whatever IPs are there, that is public IP. So is it clear? Any confusion? So let us do one practice. Private or public? Public. Private or public? Or APIPA? APIPA? Public. How it is private? Where I have said it starts 192 is the public, private. What is written? 192, 168. Then only private. Other than this is public. Understood? So don't get confused. That's why I've written all this number like this. If I've written two numbers, means you have to match both the numbers, not only one. So I hope types of IP address is clear. And always keep in mind how IP address work. Like for example, you start with 10.0.0.0. This will be the first IP. Second, 10.0.0.1, 10.0.0.2, and so on till 10.0.0.255. Next IP 10.0.1.0, 10.0.1.1, then 10.0.1.2 till where? 10.0.1.255. Then it will become 10.0.2, and similarly when it goes 10.0.255.255, then this will become 10.1.0.0, and again it will start in the same way. That is why there are 1,67,77,216 IP address from this to this. And if you have any confusion, you can write in notebook and count it also. Okay. Now the next, nodes. So these nodes are for what? To find out invalid IP address. So if any IP address starts with 0, or we write 0.0.0, means all bit 0. All bit means all 32 bit in binary. Then that IP address is used as default network ID. Default network ID means when we say human being, it belongs to Chinese, Indian, all. So similarly, when we say all IP address, it belongs to private, public, class A, class B, that doesn't matter. Then to refer like that, we use this as a network ID. Understood? So this network ID is used for two purposes. One, for the default routing. When we have to say to go in any network, use this path. So instead of writing any network, we write 0.0.0.0 via this path. Understood? So this is a default network ID when we have to refer all. Second thing, I want to block everything. So what will write? Deny any IP address. So instead we can write deny 0.0.0.0. Or we want to permit any. In that case also we will write permit 0.0.0.0. So there is two use. One, for the routing, to define the path to go in any network. There we use this default network ID, or to apply the security rules. Okay, for all the IP address. Next is, if all bits of IP address are 1, so it doesn't mean 1.1.1.1. It means all binary 1. So when you convert it into decimal, it becomes 255.255.255. Okay. So it represents default broadcast ID. So default broadcast ID means I have to send message to all, whether it belongs to any class, anything. Then I will send my message on this IP address. On this IP address means as a destination IP. When we send any message, there is two things: source IP, destination IP. So source IP will be my computer IP, and destination IP I have to send to all. So whose IP I will configure? There I will keep this IP as the destination IP. So it will go to everyone, whoever is connected in the network. Understood? It doesn't mean that someone who is not connected in the network, to them also it will go. Just as an example, when Modi ji is there and he says Man Ki Baat, so who listen his Man Ki Baat? Have you listened ever? Huh? When? Those who are connected on Akashwani or the radio on that time. So those people can only listen. Okay, because he is broadcasting from one office, and the devices which are connected on that broadcast network on that megahertz 102 or 1 is the this one megahertz is the frequency, something like that. So on that, those people are connected on the same frequency, they receive the messages. So similarly, at those who are not connected, those who have tuned 98.3, they are listening the songs on the same time. So those who are connected in the network, and if the message is sent on this as a destination IP, only those devices will receive the message as a broadcast message. Okay. So this is called default broadcast ID. Why default broadcast ID? Because you don't know. You just connected in the network and you don't know what IP address is used. In that situation, we use this IP address and broadcast the things. When broadcast is done, broadcast is always done for two purposes: query and update. If the device has any confusion, it will not talk to you. Have you talked to with your laptop and mobile anywhere? With laptop and mobile, you have talked to any other person, not with the laptop and human being. So if device has any queries, it will talk to device also. Understood? So if it is having any queries, it will not come to you and ask. It will send the broadcast in the network, and the devices connected in the network will respond for the query of the device. Or if there are some protocols which send updates to another protocol, another device protocol, in that case also it use broadcast. Okay, so is it clear? So this is default broadcast ID, and when it is used, when the device does not know about the connected network IDs, that I am connected in which network, I don't know. So then it will use default broadcast ID. Now, if all host bits are 0, see the difference. Earlier I said if all 32 bit are 0, then that is a default network ID. And if all host bits are 0, so host bits means, suppose if I write 179.100.10.0, so here all host bits are 0. This IP belongs to which class? Class B. How many network? 2, and 2 is host. So all host bits are 0? No. So if all host bits are 0, why I have shown this one? Because every class, number of host blocks and bits will be different. So based on the class, you have to see and calculate. So if all host bits are 0, then this will be represented as network ID. For what? For this specific network. Which network? 179.100 network. So if I apply any rule here, where it will apply? 179.100. Suppose 10.10. So if I apply any rule here, it will apply on this IP. Means any IP address starts with 179.100. The rule will apply only on that, not for the other IP address. Understood? So if all host bits of an IP address is 0, means it represents network ID for that network. For in this example, it is for which network? 192.168.10. Understood? So any IP address starts with this network ID, the rule will apply, or whatever we are going to use for this network ID will apply, not for other IP address. Similarly, if all host bits are 1, again I am repeating, 1 doesn't mean the value will be 1. For example, if I write here 1.1, it doesn't mean that all host bits are 1. When you convert it into binary, it will be 00001. Understood? So 1 means here this one. We are referring this one. Understood? So if all host bits are 1, represent broadcast ID for that network only. Means if broadcast message is sent on this IP, it will go only to the IP address which starts from this network ID, not to the other IP address. Is this line clear? So always keep in mind, network ID and broadcast IDs are invalid to configure because it is having different purpose and use. Understood? So this network ID and broadcast ID we cannot configure on our devices. And every network will have two things, network ID and broadcast ID. And first one IP will be network ID and the last IP will be broadcast IP of that network. And in between will be the valid IP address. So just do one practice. Suppose if I have one IP 10.0.1.0. So you tell me valid or invalid? Hmm? Why? If you say anything, there should be some concept behind it. In between. So what I have said as a rule? Valid or invalid? Class A, 3 blocks host. So all host bits are 0, all 1, then valid. Understood? Rule says all host bits should be 0 or 1. Valid or invalid? Invalid. Just now I taught you now. Invalid. You see the binary? All host bits are 0. Then how it is invalid? I am not talking about the value 1. I am talking about binary values. So don't just see 1 and say that it is valid or invalid. Convert it into binary and then see that all 24 host bits are 1, then invalid, or all 24 host bits are 0. 0 we can identify very easily. The reason is all 0 becomes a single 0, but all 1 doesn't 1. It is 255. Understood the difference? Valid or invalid? Hmm? Why still you have confusion? Belongs to which class? How many hosts? So in these two, all 0, all 1, then valid or invalid? Valid or invalid? Clear? Valid or invalid? Huh? So clear this one? Now coming to the next, that is subnet mask. Subnet mask, why we are using? Because we are using subnetting also. That is the reason we need subnet mask. else it is not required. Our computer, our devices gets confused that how many bits are network and how many bits are host. As a default, just by seeing IP, you say this much network, this much host. But when you do the subnetting, on that time, you change all the orders and IP looks the same. So that is why we need to give subnet mask and tell our computer that in this IP address how many bits are network and how many bits are host. So to represent network bit we use 1 and to represent host bit we are using 0. So here I have taken an example of class C. This is the IP of class C. So as we know in class C 24 bits are network and 8 bits are host. Correct? So when we convert it into decimal, we get 255.255.255.0, and this value is our subnet mask for this IP. When we give this value to the computer, computer convert it into binary and come to know that okay, 3 blocks is network and 1 block is host. Understood? Similarly, for class B, 2 blocks are network, so 255.255 and 2 blocks are host 00. Is it clear? Next is CIDR. So when we need to write any subnetted IP address, not this normal IP, just by seeing we can say that okay, this much network, this much host. But when you have done subnetting, there you have changed the order. So how you will know that how many bits are network and host? And when you write the subnet mask, then again we have to calculate and count. So to avoid this all, we are using CIDR. So CIDR is what? Shortest form of representation, which represent how many bits are network. And rest all you are very good in mathematics. So whatever number it shows here, by seeing this number, you can calculate if 24 bits are network, then how many bits are host. Understood? So CIDR is the shortest form of notification which notifies in any IP address how many bits are network. So slash and then we write that value, and this value is called CIDR value. Clear? Now there are two types of IP address, classful and classless, as we are in our house also. If our parents say anything, then very obedient child. What he says and we follow. And when we don't follow as per his orders and mind, then you know all the words what they use. Okay. So same here. If the IP address bits are arranged as per the class it belongs to, like here, this is class C. So class C 3 block means 24, 24 bit network, classful IP. Class B 2 block network, 16 bits, classful IP. But if see the situation where bits are not arranged as per the class, that is classless IP. In which class we have 27-bit network? No class. So that is classless. And when it happens? When we do the subnetting. Okay. So next class will be on Monday, not on this Saturday, Sunday. Because your class has started recently. So your class will go as it is. First, let me finish all the evening classes. If I call all of you, it will be like 4 classes. 2 hours means 8 hours continuously. So for your batch, this week, no weekend class. Next week, we will see. Meanwhile, I think 2 batches will finish in the evening. Then I will call next week. Okay. So this weekend, you can take rest and sleep well. So next class for your batch will be on Monday.